bit later. We'll do a coffee break after this before we go into that panel session. So, take it away.
Thank you very much, Colin. Well, I'd like to thank you all for coming here. This is what we normally refer to as the graveyard slot, is it? I'll try to make it interesting. My name is Galal. Well, it's actually, guys, my first name as well as part of my surname, so just feel free to call me Galal. It's so much easier. I'm actually a professor of information systems at Galal University, and I currently have the good fortune of being a visiting professor at UCL on a sabbatical, which lasted for just over a year. I'm sort of kind of enjoying it. I don't want to go back to Galal University just yet. Allow me just very quickly to tell you why am I thinking the way I'm going to present it to you, the way I'm going to present it to you, and what sort of things influence and shape my thinking. My very first degree was actually in management, so I studied an awful lot of business and behavioral science and economics and accounting and computing and programming and stuff like that. And my very first job after graduating from that school was actually to work as a junior organization development consultant. So again, working with the process and people and change and stuff like that. A lot of what Petra has been talking about in her presentation just before the break. They followed that by Master's in System Analysis Design at City University, and then PhD in Information Systems Engineering at Brunel, where I also taught software engineering. Now it occurred to me that I'd quite like to teach my software engineering students in the way that architects learn how to design things. Yeah, the training of architects sort of fascinated me. I wanted to replicate that, as well as my very sort of intense interest in architecture, which I discovered as I was about to hand in my PhD. So I went to University of Greenwich and actually did a part-time BA in architecture, and followed that, or more accurately multiplexed that with a master's in advanced architectural studies, which has been renamed to spatial design at UCL. Now, why am I telling you all this? Because I think to actually call everything architecture just because it's designed or it has some kind of blueprint or some kind of template is positively harmful. We are in the business of fashion, I think, and I was talking to someone over the break, and since the 70s we've seen lots and lots of fashion. Yeah? There was the fashion of structured things, everything is structured, and then there was the fashion of object-oriented thing, everything's object-oriented, and there's the architecture, and then the services, and then the more recently, microservices and AI and big data. We're constantly running after fashion, running after sort of silver bullet. So today I want to walk you through just a few opening remarks and concepts really, and then I'd like to make this a distinction between what to call design architecture and structure. Because again, one of the problems is people would call anything that has structure, oh, this is the architecture of something, while architecture really needs to be at the higher level and with some certain objective that I will be explaining later. So what is the prime role of architecture? What does it do? Is it just a design blueprint so that you build according to the blueprint and that's it, or does it give you something else? I think it does, and I really hope for your input on that and your views. I'd like this to be as attractive as possible. And then the core of this presentation really is about how we might use some called scenarios to come up with plausible or feasible architectures that will give us the qualities that we are seeking. So architecture is mainly about achieving non-functional qualities or certain properties in the artifact that you're trying to design. It's not just to have something that works and delivers some services and some outputs that you design, because you can do that in many ways. Right, and something about where scenarios come from. So let me start with just a question here. I'd like to ask you actually, what are your most difficult architectural decisions that you've made in the past or have to make on a regular basis? If you don't like the word architecture right now, just call it design. It's okay, just design, but don't get into anything else now. I don't want to talk frameworks or TOGAF or ZACMAM or anything like that. I just want to purely consider the concept, please.
I think it's when you have a new thing that disrupts the old thing.
Okay.
In other words, that you can't just evolve it. It's got to change fundamentally from where it's come from. And I think then the tension that's created between the old thing and the new thing creates a lot of sort of debate, argument, discussion, whatever. And the new thing itself can often get killed because the old thing doesn't want it to happen.
Yeah.
I don't know.
Who doesn't want? The same doesn't want to, or someone
Yeah.
else doesn't want it to happen. Yeah.
And the politics get involved.
Okay.
Yeah.
Excellent. So, okay, so there's the disruption, yeah, that causes you to want to change things from one state to another state. But can I ask, is the target state or the desired state always agreed upon? Is it always that clear?
No.
Exactly. So really, it's about, I'm not even sure where I want to get to next.
Yeah.
Some of the work I did actually in between all these things I've done is the work in requirements engineering. And again, all of the sort of known wisdoms in that area that people don't know what they want until they've seen it, not just they've seen it, until they've used it for maybe a few months, stuff like that. So the question of constantly trying to hit the moving target, you really, the target is by all means not clear. And if it's clear now, in a few weeks or a few months' time, it might be something completely different. Yeah? Okay, so I'm glad you mentioned that. Laurel, anything else? I'm asking about difficult architectural or design decisions that you've had to make in your work or anticipate to have to make on a regular basis.
There was one I'm thinking of, which was actually shutting down the company I worked for.
Yes.
So I was employed by a company and I had a project, and we were working on the decision of do we shut the company down that was currently employing me. So you could say, well, actually that's disruption to an extent, because you could argue it was, and some of the characteristics you put in about the old view fighting back. But in terms of what was difficult was actually emotionally difficult.
Yeah.
I'm trying to build a business case to put myself out of a job.
Right.
It's a really tricky thing to do.
That's a bit drastic. I think it just blows out the whole thing, like completely. You shut it down.
Big, yeah.
Okay. I guess the common thread here would again be something about reasoning and debate and rationalizing a decision, whatever it is.
Yes.
Yeah, because even if you want to make a decision like this, you have to weigh benefits and costs, don't you? At the end of the day, it's an economic decision, and maybe shutting it down would be actually more cost effective in the long run.
Yeah.
So again, you have to engage in some kind of a debate and reasoning amongst the stakeholders who actually have to make that decision, who will be affected by it. Great. So reasoning, debate, and representations, and in a couple of presentations actually earlier today, I saw interesting things here about managing the stakeholders, having a dialogue with them, especially in Petra's presentation just before me. All right, okay. Now, as I said, architecture, we just tend to run after sexy and attractive titles and headings. Not all design is actually architecture. Yeah, some of it is, but not all of it. But certainly, if you want to do design, to do architecture, then a lot of it is going to involve design. I mean, I've put an expression here which architecture is subject of design, but it's actually not strictly true, not 100% true, because I can imagine things you can do in architecture which is maybe not design, but a lot of it is in fact design. So, I forgot I have this already. Right, okay.
Is all architecture design?
Most of it. Most of it. As I said, this sort of expression is not called strictly, mathematically, but some of the architecture would not be design, but a lot of it would be. A lot of it would
So
be.
that diagram is...
Yes.
Yeah.
Yeah, as I said, it's just not very strict in that sense. But a lot of it would be design, not all of it. Because I can imagine things that are not technically strictly design. But I mean, the reason I put that in is that some people actually would classify architecture as the mother of all design disciplines. I don't know if you agree with that or not. But if you want to talk about design anywhere, then definitely when you started to design homes and houses and buildings, it's where you man would probably exercise their first design, explicit design activity maybe. I want something that needs to be said here about the fundamental or the essential role of architecture. Is it just a design blueprint? Well, there's something else. You come up with an architecture or do architectural reasoning because you want to help, you want to manage, you want to promote, you want to generate certain desired properties and qualities, not just a thing that works. I remember when I was teaching software engineering and programming to my first year students at Brunel, we used to have an exercise for them to write an essay with the title, "If it works, it's okay." If it works, it's okay. So if the program works, okay, obviously, it's a bit of a trick question. It's supposed to find out that no, if it works, it's not okay. It's not enough because there are other properties that needs to be there. Things like it has to be extensive, it has to be robust, it has to be maintainable, etc. And various other qualities that you want to get. So architecture really needs to determine what is the component that actually can have beneficial or positive effects on the rest of the properties that you want to merge. Because really we can say that at any one time you can have a number of equivalent architectures, computationally equivalent. They all do the same thing. The question is, in what way do they actually achieve that? So, well, if we look at this sort of nice sort of architectural interior design, one by one famous English architect called John Paulson, this is really a lot more about that space that you can do things in. It's about the visuals, it's about the light, it's about the air, it's about the circulation, it's about lots of things than just the sort of the immediately perceptible function of an interior layout. Now, I've come across work by a guy called Stuart Brand. This is actually part of what I did last year for the same conference on architectonics, the concept of architectonics, and the issue of adaptability and change. Stuart Brand noticed these sort of Victorian buildings in San Francisco that have been in place for 200 years and they've been constantly adapted and modified by the owners, much loved, and they are very flexible with whatever functions they want to throw at them. And if not, obviously, see lots of these examples in England, where when you have a house like that, you can actually convert it to flats, you can keep it as it is, you can turn it into business, you can turn it to whatever you like. So this sort of ease of change is expressed in this diagram, again by Brand, where he says these buildings can actually evolve and adapt because you have constructional layers that are loosely coupled from each other, in the sense that you can change the surfaces layer, and the arrows here and the frequency of the arrows and the thickness of the line express how frequently this layer changes. Now, if you can change things in this layer without having to change adjacent layers, then you have more agility and more flexibility of the architecture you have. So these layers are decoupled or are loosely coupled from each other. They slip past each other without having to affect the next one. Now, before that, I was actually studying, as I said, system analysis and design, and one of the methods we've come across is the JSD method. And the striking thing about the JSD method of systems and software development is that it will explicitly say, do not start with asking what the requirements are. So you should not start your analysis with asking what does this system need to do. So it's not capability, it's not function, nothing like that. Ask about what is the fundamental subject matter of this system, what is this system about, and model that first. So that becomes your base layer. And once you've got the base layer right, and you obviously can connect that to the concept of objects, yeah, and we have different types of objects in an object-oriented system. Once you've defined this properly, you can then plug in functions that are not fundamentally sort of coupled or strongly geared to the previous layer, to the extent that when you change functions, you necessarily have to change the fundamental fabric of the building, or the things like the database, for example, data structures it has to maintain, and it has to sort of populate as time goes on. So this decoupling from function, or between function and some other layers, some other construction layers of the system, sounded to me like this. It's like about loosely coupling layers of the system and not worrying about the function and not basing or revolving all your architectural decision about the function of the building. It's about what is this building about as a fundamental mission. So, to simplify this a bit further, I mean, there's some sort of more theoretical writing about this, where it says, well, most buildings in the world, we can identify two different modes of building. One is stability and the other is volatility. So the stable is the earth, the thing that doesn't move very much, doesn't change very much. And then the volatile will be more frequently changing the tectonic frame, the sort of the shell on top of the earth, whatever. So there are like two things that are differentiated by the likelihood of change or stability, or being influenced by whatever things that might disrupt them. And you can think, okay, if I have a building that is existing in some site, whatever happens, the site is not going to change, is it? Because it's just so fundamental to it. But of course, there's always the counterexample of, okay, let's look at a totally different culture, a totally different mode of use, if you like, where you have a tent, nomad's tent. Is the site the most stable thing? Is the site the most unchanging thing in it? It's not, is it? Because a nomad would simply, wrap up the tent, all the fabric around it, or the skin of the tent around the structural elements, which maybe these sort of stakes or these reeds or whatever they use to construct the tent, and they would hoist it on a camel or a llama or a donkey or whatever, and they move it somewhere else. So this indicates to me that actually it's the problem context and the domain that you're trying to serve that will establish what are the sort of stable and changing layers in the system. That's why I'm not very much in favor of going to construct an architecture by trying to instantiate a TOGAF template or a Zachman template, because it has certain cultural and contextual assumptions built into them, which normally come from technical domain. Because, for example, we have to start with the business capability, or we have to start with the data, or whatever. It doesn't matter really. I'm not arguing here for one being correct and the other not. I'm just saying, wherever you start with, whatever the layers are, and how you decide to sequence them, depends on the culture, the context, the organization. Understanding the problem and the organization tells you which bits of the artifact you intend to build will be stable or will be changeable. For example, normally, if I go back very briefly to this JSD diagram, we would normally say, actually, the interface is changeable, isn't it? It's very easy to change. It's the thinnest layer, maybe, yeah? Most systems, at least, yeah? And you can, change the colors, change the screens, change the interaction diagrams, interaction sequences with the user. But actually, if you think of something like Facebook, or some kind of system that is out there for mass use, you don't want to change the interface so often, yeah? We all get very irritated when Facebook decides to change something in the interface. Although in theory, that's the thing, is that's the easiest, most easily, most rapidly, most frequently changing part of the system. Well, it isn't, because the problem domain has changed. So really need to consider the problem domain very, very carefully. Now, we come here to an epistemological problem. With respect to your domain, which would be your base layer components, which would be the interface, the equivalent of, that is, the equivalent of in terms of the frequency or likelihood of change? Well, I didn't need to do that. I cannot find my, sorry, this is the brand new machine, brandish, newish machine, because I only had it yesterday. Big massive crash last week, and then I was actually going around trying to borrow a machine at the last minute to get this presentation going. Right, let me just try something else. Right, okay. Yeah, so I basically already said this. What are the layers, and what is the most sensible and reasonable sequence and arrangements between the layers that gives you the non-functional qualities that you desire for this particular system? Again, a template would normally assume that there are certain qualities you want and there's a certain hierarchy of layers that you want, but maybe that's not the case. So, again, this is from the book by Brand, the title of which I forgot to mention, How Buildings Learn. How Buildings Learn, what happens after they build. How Buildings Learn. It's about adaptability. And he said, well, let's try some scenarios. Let's try to think what scenarios can actually be for your artifact, which is in this case obviously an architectural project or building, but maybe it's not. Maybe it's not a technological artifact. So here we've got two dimensions, could be other dimensions if you like. There's a stable environment, or stable market environment that we're working in. Another one is fluctuating. And as regards the size of the organization or the company I'm working for, it can be either small or large. So if it's a small organization working in a stable environment, then you can do something like this. Yeah, small components, possibly changeable, possibly plug and play, or pluggable and unpluggable with relative ease. Relative, that is, there's nothing that's completely easy or without charge or without cost. There's always a cost. The question of how much is the cost relative to the change that you wish to affect, or relative to the disruption you're suffering and trying to accommodate. If it's a small company but existing in a fluctuating environment and lots of things changing, lots of disruption anticipated, then you go for the Arch Commanders kind of thing, sort of plug and play, very plug and play, provisional spaces, yeah? It's like actually when you're having a cafe and you decide not to have any furniture in it, hardly any, well, everything is movable. Yeah, even the walls, you can sort of stick wooden boards on the wall, for example, that sort of stuff. Everything is moved around because you don't know what's going to happen tomorrow. So because you anticipate this scenario, try to instill maximum flexibility in the architecture. The same thing for, if it's a large company, stable environment, or maybe then you can go for the IBM approach, big, massive headquarter, spending millions on it because you're in a stable environment. In 20 years' time, there will still be IBM, etc., etc. So obviously, at a certain time, we didn't think it might exist. If you remember in the 80s, the big blue issues and stuff like that, some big companies have disappeared, as we know, although they assume that they're large enough and stable enough that this will never happen to them. If it's a large organization in a fluctuating environment, you've got the Spanish Armada situation. A lot of what I'm saying here actually connects to some of the methodology of the developing system, whether you want to follow an agile approach or evolutionary things like that. But again, the idea of following some kind of scenario-guided approach to design is really very important. So this thing will disappear actually when I put the slides up because I haven't got copyright clearance. It's a scan from the book, so forgive me, but I'll put something else that you can actually see later. So flexibility really is relative because if I say I want a flexible or an adaptable system, to what extent or in what direction do you want it to be flexible? And last year I should remember answering one of the questions or commenting on one of the questions using the example of the samurai sword. If you don't know how the samurai sword is actually constructed, once it's forged and heated, etc., it is cooled differentially. The sword maker puts an awful lot of mud on the base or near the base and less mud at the top. And he dips it into water to cool it. The result is the top edge of the sword cools much faster than the bottom part of the sword, making the edge, the top edge, much more harder than the lower one, and the lower one will be flexible because it's cooled at much lower speed. Differential flexibility. You cannot have equal flexibility in all dimensions. You cannot strive for ultimate flexibility everywhere. You have to decide where flexibility matters most. Now, the sword maker made the decision because he understands the domain of sword fighting. And he understands how the fighter is going to use his sword. Yeah, it's that sort of idea. So what I'm advocating here is that we understand problem domain very, very carefully. And once we've had some kind of, this is actually a domain model that is built from qualitative data and using qualitative data analysis. Once you understand the domain, you can then try to run several scenarios through it and say, okay, what if certain changes happen? How many of these nodes or components or elements will I have to change to achieve the desired property? And there are some examples here, like, okay, if you have a law firm that's going to merge with another one, so what's going to happen? Is it going to merge with another law firm in the same country or in different countries, etc., etc.? What's going to happen? Yeah, you have to try and do that. Where the scenarios come from, there are several techniques. This is not comprehensive. You scan the environment, do environmental scanning if you want. You can look at and measure trends. You can liaise and engage stakeholders, and stakeholders engagement has been referred to a number of times today. Even your own staff and employees might be a source of ideas about what scenarios can actually happen. But you need some kind of supporting mechanisms for scenario development. You need information management. Yeah? Just good old information management and propagation to the people who need to know about it. You need to communicate with stakeholders and manage the communication and document the communication results. You need to monitor assumptions. If you develop some scenarios based on some assumptions or trends or anticipation, you need to monitor the realization of these assumptions, because if they change, they might invalidate some of your scenarios or cause you to change them. Configuration management. I did start on time, Galal, that's why.
No, it's just got to open the room. So
right, okay. And finally, the idea of having a crit, and this is something I learned in studying architecture, we always had things called critiques, yeah? Well, people would put up the designs up, and okay, let's see what happens if this particular scenario is realized for this particular artifact you're thinking of. There's stuff here about an architectural scenario process. I won't go through it, but let me just show you one of the evaluation methods for scenarios. You can simply construct a grid like that and come up with various scenarios, explain where scenarios might come from, versus several architectural alternatives. And architecture, you always need to consider alternatives, because you need to measure or understand to what extent each scenario would affect the architecture, or to what extent each architecture will accommodate one or more scenarios. And obviously the one that seems to accommodate the majority of scenarios may be a winner. Maybe you want to add things about certain qualities in each of these architectures that you care about, which some people call them perspectives. One is security perspective, this is a paradigm over everything else, maybe it's the flexibility one, maybe it's the robustness element, etc., etc. Right, so just some notes about, just a few sentences about studying the domain, folders, rigorous analysis of the data, relying on shared models, always go for visual representation, maybe big charts from the wall, common war room, we can actually debate and talk to each other, aids communication, understanding, and engagement as well as buying if you're lucky. Strong traceability between models, elements, and the data. I need to give priority to enabling good debate. I just call this a good debate, and that will be it. I think I'll stop here. Am I on time, Colin? Yeah?
You have a couple of minutes left.
Okay, what?
A couple of minutes left.
I think I'll just leave these to questions, and yeah, okay, maybe I'll just show you my take-home message slide. So structure, design, architecture are actually different. Shouldn't call the structures of design architecture for the reasons I mentioned. You want to promote overall properties and quality. This is the main mission of good architecture. You want to, there are many possible architectures. They all do the same thing, but they vary in terms of qualities, and you have to prioritize the qualities that you're most interested in. Yeah, which ones are the most important ones for you? Again, using scenarios and analysis with the stakeholders. Good architectures support emergence and the management of non-functional qualities and properties. Which qualities are in focus varies with the context and expected scenarios. Scenarios can help you in the reasoning and choice of architectures for a particular domain. And finally, you have to monitor your assumptions, because there's always a epistemological issue. Have I got it right? Was that correct? So you need to be willing to revise and maybe adopt a bit of an agile mindset here. Right, thank you very much for listening and for coming to the session.
Make it a note. Any questions? We have a coffee break afterwards, and we have questions afterwards. No.
He must be one of the very few people who's got so many degrees to his name, covering both EA and building architecture. What interests me is, what in a nutshell is the challenge when as EAs we look to building architecture and try and draw too many analogies.
Yeah.
I've had a couple of discussions today where someone said, I hate the way we try and draw analogies to building architecture. We're much more town planners than we are building architects. And just get your insight on that, really.
Well, I think the two domains are very, very close. In architecture, actually have many people who do architecture participate in town planning and the other way around. In fact, the master's I did was more focused on urban morphology and urban design than building architecture per se. So the two fields are very, very close, and the reasoning methods are very, very close. I would say that the take-home message for all of this, what I've personally learned, is really the primacy of the process. It's the process, it's the debate, it's the interaction, it's the crit. It's the communication and the visualization models that you use, the visual that you use to communicate and bring the idea closer to everybody else. Yeah. So I didn't mention that I did quite a few consultants myself, designing large systems, and I never ever subscribed to any of the sort of 30-odd methodologies I've studied. Yeah. And one method I would start with something like context diagram from data flow diagrams, and then move on to an object-oriented, and then come back to something that JSD did, because I understand what each method or each framework can contribute to this particular problem I'm working with. I would never blindly follow a particular methodology from A to Z and say, here's your architecture, I've filled in all the templates. And this sort of preoccupation of the framework is really very powerful. I think Petra was here. I very much go along with what you said about it's the engagement, it's the process, it's the debate, it's getting people on board, and actually getting to know the ideas and what they're thinking about. Because actually will change their mind once they've understood you better. They do. And you need to capture that. You can't say, oh, sorry, you've said this 2 months ago, I'll put it in the architecture now, it's immutable. That would be wrong. And again, the idea of enabling an architecture that's actually evolves because requirements change, because environments change, because strategies change, because legislations change. You don't want to redesign everything once a change of that type has happened. Last comment.
Or we can start opening the doors up.
Right. Thank you very much. I'm happy to continue the conversation if you'd like me to help you with anything. I'm all for it. Yeah.
Thank you so much.